Hello, APE students. Time to learn about petroleum. So this is the second part of the 6.5 unit lecture. And this one will be coming after the lecture about coal. And now we're going to talk about petroleum and possibly all the way into natural gas. Let's see how long this takes. So petroleum is cleaner than coal, although still has many of the same issues for environmental problems. So what petroleum is a fluid mixture of hydrocarbons, water, and sulfur that occur in underground deposits. So I should tell you that your notes, the place you should be taking notes, and go, pause the lecture and go grab your notes, page 15. And you're writing in petroleum is cleaner than coal, and you're writing in all those things that are in red, okay? So the fluid nature makes products more suitable for mobile combustion applications, like in vehicles. It's much harder, like you can use coal for a train because it has a place for it and stuff, like for that's how they used to make trains go, using coal. But petroleum you can pump and you have to refine it, so we'll talk about that, all right? Pause if I'm going too fast and write those things down. Okay, so this is how oil is formed. Similar to coal, okay, except that, so it's the same idea, but it's going to make a different, it's going to transform the dead organic matter into a different material. So instead of coal, you're going to get oil. And so this is mostly formed from phytoplankton, from algae, from 50 to 150 million years ago. And I just always say 300, 200 million years ago, a long time ago, hundreds of millions of years ago. No way we can use it in a sustainable way, especially at the rate that we're going. So its porous rocks are covered by non-porous rock. And over geological time, the algae or the algal remains fill in the pores and form petroleum. So that's what my face is over a little bit here, but this is in your lecture notes so you can see that, okay? So petroleum is less dense than the rock. So the rock is deformed as it migrates closer to the surface where it can be drilled and extracted. So transportation is by pipelines or super tankers to a refinery, okay? So what's happening here is the oil is trapped underground and you can drill down and pump it up, okay? And then transports all around the world in these super tankers or pipelines. Oh, and so they take them to a refinery because this is going to be crude oil that needs to be refined into its usable substances. So crude oil is the liquid petroleum that's removed from the ground, and then natural gas is burned off or extracted for separate fuel. So you make, while the crude oil is forming into a liquid form, there's also a gaseous form that's formed, which is natural gas. And that's a little harder to collect, and I'll talk about that in the next unit. So crude oil can be refined into tar and asphalt, gasoline, diesel, kerosene. It depends on the temperature at which they are boiled. So this is a general idea of how this works. You don't need to know too many details on this for the AP test, but you take the crude oil and you boil it and then you distill it. So this is just a simple chemistry kind of a thing, or at least the idea behind it is. And so you get different types of oil at all these different places. So that's why like diesel is kind of a dirtier, different kind of material than gasoline is. So that's why some cars run on diesel and some cars run on gasoline. And so this is what happens when it goes to a refinery. So the process here takes a lot of energy. It's always important to think about, when you're thinking about an energy, you want to think about the energy you put into it to get the energy you're going to get out. So oil must be refined, which takes energy. You have to use something, perhaps coal, to boil to refine the oil, okay? It's not in a usable format when you get it out of the ground. So oil refining is complex and dangerous and requires significant monetary requirements. So a barrel of oil is 6 160 liters or 42 gallons. Okay. So that is all the stuff to write down on page 15 as we're going along here. Now we're going to fill in this chart. All right. So oil refineries, that's what's going on there. It's just the processing. Okay. So what oil is left? So first of all, you're going to go back to that map on page 10, was it? Right? Let's look back. So this is the map on page 10. So this is where the oil is. And most of the oil, as you can see on this blown up area here, most of the oil is in the Middle East. So that's why you hear so much about this country being an oil-rich country. There's a lot of oil up in Canada. There's some in the US, Mexico, Russia. Okay. So the top 20 countries have most of the world's oil, at least from 2006. So you can kind of draw in here. You can use a different color for oil and just sort of give yourself an idea of where the oil is. So that's for you to go back. So get another color and put that in. We'll let people show their maps on in a Zoom session so that you guys can make sure that you have these done correctly. Okay. And then we'll talk about the Alberta tar sands. So this is okay. So this is an article for you guys to read. We can skip this for now. And then, okay, so the oil that's left. So this is where you are filling in on the packet, okay? So where is there 178.8 billion barrels of oil left? That would be Canada. Okay, so take some time on page 16 and answer those questions. We'll give you a little bit of time to think about that. Okay. And then please, after you've done this, we're going to go over this in class and make sure that you get all of these correct. Okay? Cool. So pause and fill out the chart at the top of page 16. And then this is an article to read. Right now, it'll be extra, just for the time that we have. Okay, so we are into the advantages and disadvantages of petroleum or oil. So I might use those interchangeably, okay? Liquids are convenient to transport and use, so they're ideal for mobile combustion engines like cars, trucks, and planes. That's an advantage of petroleum. A second advantage is that compared to coal, it's energy dense and cleaner burning. So it releases 85% of the CO2 that coal would when burned. So it's better for the environment than coal. Still not good though. The disadvantages are that toxins are released into the atmosphere, things like sulfur, trace metals like mercury, lead, and arsenic. So you're writing that down. And then there's the potential for spills and leaks, kills many wildlife, habitat destruction due to pipeline and oil well construction, gas flares like methane, greenhouse gas emissions, and risks for people who are pregnant. It is very, those kinds of things let off a lot of toxins, and people that are pregnant are uniquely and very much more sensitive to these kinds of things. So that's one of the disadvantages. And now we're going to talk about a few case studies. So we have three case studies. And the first one is the Exxon Valdez oil spill. So this happened in 1989. A supertanker crashed into a reef in Prince William Sound, Alaska. So the name of the ship is the Exxon Valdez, and 42 million liters, that's 11 million gallons, leaked into the water, and 500,000 birds and thousands of marine mammals were killed. This was a really big deal. And in fact, when I've gone up to visit my sister in Alaska, and we went to Valdez, they have a whole museum for this, and they're still seeing the effects of this oil spill back all the way back in the 80s or the end of the 80s. So the Exxon Valdez oil spill is a very important one to know about. Next study is ANWR, which is the Arctic National Wildlife Refuge. Oh, Arctic National. I always thought it was Alaska National Wildlife Refuge. Arctic, okay. So exploration might yield up to 1.4 trillion liters of oil and natural gas. So a lot of people want to drill here, and different administrations have different policies on this. And Obama stopped the drilling in ANWR, and I'm pretty sure Bush opened it up again, and now it's probably going to get closed again. It's going to be pretty hard to leave that oil there, but it is in such a sensitive area. So the opponents say that it will harm the pristine habitat, and as the human population, the human population will also be harmed there too. So there's a lot of controversy on will we drill in ANWR or not. So that's an ongoing thing. And then we have the horrible, Exxon Valdez was the worst oil spill for the longest time. And then we got a worse one. And unfortunately, there's going to probably be another worse one than this one, just because we're still using oil. And the fact that we're using up oil, it's making it harder and harder to get the stuff that's left. So we're going to keep having these big issues as we're using oil. So the Deepwater Horizon in 2010, there was a huge explosion at the British Petroleum oil rig in the Gulf of Mexico. BP is British Petroleum, a really large global oil company. They released 780 million liters, that's 206 million gallons, over 87 days. 6,000 sea turtles, 26,000 marine mammals, and 82,000 birds were killed that we could count. And this was just a crazy thing. So what this is a picture of is this was a video feed that was going. So what happened was this oil rig out miles off of the coast, it exploded, and then the pump that was underwater. So there was a huge drill that went down, and they were drilling in the ocean, and then this thing broke off. And then it kept spewing oil into the water instead of going up into here. So people died. It was awful. And there's a movie about it. You can watch the movie Deepwater Horizon, and it's dramatized, but it's pretty dramatic in real life too. And this live feed of the oil just spewing out, they couldn't stop it because it's like a mile underwater, and it's really powerful that the shutoff, that everything just fell all apart. The shutoff valve didn't work right, and they were trying to pump dirt and golf balls for some reason for a while there. They were pumping stuff in there to try to stop it, and then they were trying to drill from the side. It took 87 days. So when this was going on, and it was happening during while I was teaching apes, we actually could watch the live feed of the oil spewing into the water. And it was just so horrible. We just watched it for a while, just with our mouths open, gaping, going, oh, it won't stop. It was horrible. It was horrible. So this was just an awful disaster. So the Deepwater Horizon oil spill by BP. So sorry. So here's a video of it. And it's not working right now. Anyway, so you can watch that video if you want to. You can look things up about it. Just believe me, it's awful. Okay, so now there is a YouTube video that you can watch. So 5 years later, wildlife is still suffering from the BP oil spill. So these are things that you can skip, or I'll try to come back to them if we have time. Okay? So watching them gives you a better idea, and then it has a whole video that you can watch and do the answers on, but don't worry, I'll tell you if that is required. I'm going to skip that for now. Yeah, so much stuff to get through, right? Okay, so now you've got natural gas. And let's just keep going here, right? I think we can get this done. So natural gas, you have a schematic, you got the picture right here, okay? And then on the top of page 19, natural gas, it's the cleanest of the three fossil fuels. And what's really cool about this too, so it exists as a component of petroleum. So you write component of petroleum in the ground as well as in the gaseous deposits separately. Okay, so the gaseous deposits. So this is gas. So basically, we have the three kinds of fossil fuels. You have coal, which is a solid, oil, which is a liquid, and then natural gas, which is a gas. So we have the three forms, solid, liquid, and gas. That's important. And then they were formed differently underground. Okay, all of this happens without oxygen, and that's why they're so combustible. Because when you add oxygen, you burn things, right? So all this stuff is happening underground. It's happening anaerobically. That's why it breaks down like that. And then just, the whole cycle of everything. If you don't have oxygen, you add oxygen, you burn it. And it's just a whole cycle. You really want to think about it as a whole cycle. And it's a carbon cycle. Very important there. Okay. So I'm going to keep going through this, and don't worry, we're going to get this again too. All right. So it's 80 to 95% methane, and the rest is ethane, propane, and butane. So when I say natural gas, I often just equate it to methane, and methane is CH4. Okay, so let's talk about the uses. Oh, it's lighter than oil, so it lies above oil in the deposit. So you can see here, so that's where the gas will come off first a lot of times when you're doing your oil pumping. All right, so here's some uses. It's used for electric power, transportation, commercial, residential, and industrial. So you need to write down the three main usage, which is going to be for industrial, electric, and residential. So many of us have gas stoves or gas ovens or gas heaters. Okay. And so that's what we're talking about with the residential, and then commercial too. Okay. So it's not used as much for transportation, but it is used a lot for electrical and industrial usage. So industrial process is number 1, electrical generation number 2, and residential heating number 3. Those are the things to write into your notes. All right, so the advantages are there's fewer impurities. It emits almost no sulfur dioxide particulates during combustion. It emits 60% of the CO2 of coal, and it's convenient through pipeline delivery. So they can deliver gas through pipelines also. And if you burn gas in your house, that blue flame, when it's being completely combusted, it's not sooty, it's not bad. You don't want to burn coal or firewood inside your house. That's why you have a chimney if you're having a fire in your house, right? But natural gas burns really clean, and that's why we can use it in our stoves. So the disadvantages is that escaped natural gas, methane, is a potential greenhouse gas. So this is something you'll hear over and over again. But CO2, if you set CO2 as the heat trapping capacity of 1, methane is a heat trapping capacity of 25. So it's kind of like when you're thinking about global warming and thinking about it as a blanket around the earth trapping heat. You can think of CO2 as like a thin sheet, it traps some heat, but not tons. And then methane is like a wool blanket, a really cozy comforter that traps way more heat. So each molecule of methane traps more heat, 25 times more, and you'll hear somewhere in those ranges and stuff, but that works for that idea. So you basically, and then the reason that CO2 is talked about more as a heat trapper is because there's so much more of it. There's more than 25 times more methane. But you really want to be careful anytime you release methane because it's such a potent heat trapper. All right. Methane emissions come from animals and from humans. So farting and burping gives off methane. Okay. Okay, and then the number 2 disadvantage is, oh, and then the question was which animal does lets off the most methane, and it's the Western cattle. So eating meat leads to methane emissions. And then we've got hydraulic fracturing. So this leads to groundwater contamination and possible toxic chemicals. I'll try to show you guys this. If you just look up water on fire, you can watch this video. And what's happening is in her backyard, they had a methane, they have hydraulic fracturing going on in her backyard, and it got into the well. So when you frack, we'll do more about fracking too, but when you frack, just like saying that, when you frack, you fracture the rock, which lets the gas come up, and so you can capture it, but you also can let it get into aquifers underground, and then you can light a match and your water will go on fire, which is really terrifying and shows you that there's a lot of methane getting out. Okay, so this is how your drinking water gets fracked. So the fracking fluid is pumped underground to fracture the rock. And then this fractured rock, where you're supposed to be able to bring this all back up and capture all the methane, it's leaky because it's a gas. And this fractured rock allows the gas to get into the water. And then when you pump the water into your house, there's methane, and it will light. It's not lighting the water on fire, it's lighting methane on fire, but the methane comes out with the water. Okay. So shale gas extraction. So this is this idea at the well, you go in there. I mean, it's really crazy. It's so crazy. Okay, so it's really important to learn about that. We'll talk about that some more in class also. Okay, so here's some methods of extraction for oil, coal, and natural gas. So the method of extraction for oil is onshore and offshore drilling. So this is an example of offshore drilling, and then they just pump the oil into there. So this is very harmful and very expensive and prone to explosions and problems. Okay. Method of extraction for coal is underground and surface mining. And a method of extraction for natural gas is traditional drill and then separate from oil. And then the unconventional, which is getting used more and more and more, is fracking. And that comes from shale gas. All right, so now we have a table. I'm going to keep going here. Feel free to do this in chunks if you want to. That's the nice thing about having pre-recorded lectures. But so what you're going to do here, you have in your notes the same graph, okay? And so you're going to, let me just check here. Yeah. All right. So fill this in. So read through the seismic noise and disorients fauna. So the noise is going to disorient animals. So like when you're doing offshore drilling, you mess up the mating patterns of whales and all kinds of stuff. And so go through and read each one of these and then make a mark on your on the table on page 20. Okay, so you can pause and do that. Let me see here. Let me just exit this for a second. Okay, so you can see, so I was over this. So these two you need to fill in too. So maybe this is the one that you want to look at when you're filling in the table. Okay, so I'm going to go back to the presentation. Yeah, see how I'm covering that up there? So look at that other one. And okay, so energy intensity is the energy used per gross domestic product, okay? So this is what's kind of interesting, is it's really confusing like how the United States uses different kinds of oil. So for economic production, so things that are more efficient, less energy intense, so we use the more energy intense one. So that's what the United States uses. For weather, we use things that, for weather, we have very low and very hot. For mass transport, we don't have very many things used. For size, we're larger. For commute distances, it's longer. And then for fuel economy, we have high fuel economies. Okay, so this is something that helps you kind of compare up and down, right? So you can have like the high and the low, and then say which ones the United States uses. So it'll be high, low. The weather is mild or moderate. So what influences how a country uses energy? And then the little flags tell you which ones the U.S. does. Okay. So now we're looking at different countries, the tons with the S per equivalent per million. Okay. And this is not. Okay, so in your lecture notes, this is not following along right now. Don't worry about it. Okay, so how come the energy efficiency of the US is near the world average? We're using energy, but more efficient technologies. But the problem is population growth and the growing number of ways that we use energy to ensure overall our energy is not decreased. So, so now we're going to just go into this idea of the Hubbard scale. So I'll talk to you guys more about the answers on page 21 during class time. But this Hubbard scale, this is really interesting. So the geophysicist, Dr. Hubbard, made this idea that we would be hitting peak oil production in 2000, which is like right around now. But he made this prediction back in the 90s, and we were like, oh no, we're not going to get any of this oil. So the peak oil is at what point half the total known supply of oil is used up. So you're writing down peak oil on page 21. And then look at what actually happened. So he was like, we're going to reach peak oil. And then we started to go down, and we weren't able to make any more because we don't have any more oil. And then we started to frack. That's what happened there. Okay. So we started to frack, and that got us more oil. So we actually found more oil. It was always there, but we found a way to get it, which is through fracking, which is incredibly bad for the environment. So we're kind of getting desperate with our ability to get to oil. All right, so this is a quote for us to look at, to think about. So this quote came from this article, and I wanted us all to think about it. So we're going to talk about this in class later. So the Stone Age didn't end because we ran out of stones. So write that quote down. And what does this quote mean? How does it apply to the use of fossil fuels today and in the future? And what type of people do you think would agree with this statement? So think about that. The Stone Age didn't end because we ran out of stones. So we are talking about this as it relates to the oil age. So see if you can kind of imagine what that might be. Will the oil age end if we run out of oil? What made us get out of the Stone Age? We'll discuss. And thanks for listening. Next is nuclear energy. And I've got some nuclear on my nail for you. Bye.